7.2 angle relationships in quadrilaterals. So the sum of all the interior angles of a quadrilateral, they all add up to 360. So we're talking about A, B, C, and D. Okay? Now, the sum of the exterior angles of a quadrilateral, again, 360. So that's quite easy to memorize. W, X, Y, Z. So just as a review, exterior angles, you just extend the lines that make the four sides of the quadrilateral, and it would be the one on the outside, the angle on the outside. Okay, so example 1, find the measure of the unknown angle. So if we take a look at this quadrilateral, we're dealing with interior angles. Okay, so we can actually take a look, and we know that this is regular because we have 60 here and 60 here. And then if we add up 60 and 120, if you actually think about it, this is like a logical way of doing it. This adds to 180. Well, 180, this is not only C pattern, we can assume that these are parallel now. This is not only the C pattern that add up to 180, but also this would be half. So this would be regular, regular being that these two are 60 and then these two are 120. To actually formally solve for A, we would do, and you have to show this work, 120 plus 60 plus 60 plus A. So there's our A value. And we know that all of these are going to add up to 360. So if you add up these three numbers, so we have 120 plus 60 plus 60, we're going to get 240. Okay, so 240 plus A equals 360. And bring that 240 over, it becomes A equals 360 minus 240. And these are all in degrees, right? And we get that 120. Just double checking there on my calculator. Okay, so 120 degrees, and then I always box my answers. Okay, so in the second diagram here, this is a quadrilateral, so it's 1, 2, 3, 4 sides. Every side is extended, so then we have A, 40, 70, and 95 as the exterior angles. So this one's not regular, this is very irregular, but we know all the exterior angles in any polygon are actually going to add up to 360. So 95 plus 70 plus 40 plus A, again, equals 360. So quite easy to memorize for a quadrilateral. It's 360 inside, 360 outside. Okay, so 95, 70, and 40 add up to 205. Okay, and then just bring the A down, plus A equals 360. We're going to move that 205 over. We're going to get 360 minus 205, and we're going to get an answer of 155. So 155 degrees for A being that exterior angle right there. Okay, we're going to deal with transversals now. And what a transversal line or transversal is it's just a line. So it's an actual line that intersects a pair of parallel lines. So in this diagram here, we have these two horizontal lines. They're parallel. We can see that they're parallel because of these little arrows here. Okay, and a transversal just intersects it. So it just cuts it in half, or not even in half, it just cuts through it. Okay, transversals are used to solve angles in quadrilaterals when there are parallel sides. Okay, so just remember there has to be parallel sides. If we can't always assume that two sides are parallel, we did in the previous page because of the angles and like the measurements were given to us, so we can see that they're parallel, but we can't ever assume unless they have those arrows on them. Okay, so there's going to be 3 rules that we follow. I know that these were covered in elementary school as well, and that's why I kind of introduced it on the previous page, just as a recall. So there's the F rule, which is corresponding angles, and these angles are equal. So this angle would be equal to this angle. And just as like a little bit of a review, this one, these two lines would be parallel. and then I'll do it in red. And this would be the transversal here. Okay, let's be consistent. This orangish red is going to be the transversal. Okay. Okay, next one, Z rule. So alternating angles are equal as well. Okay, and again in blue, these two lines here are going to be parallel. And again in that orangey red, this is going to be the transversal. Okay, so x equals x. Just to show you, let me see, black. Okay, a Z pattern can also look like this. And then these two would be the x. Like these two would be equal. Okay, so it could be a Z that looks like a normal Z, or it could be pulled out. Okay, and that's because if we were to extend this and this here, these two are going to be equal. So it's the same thing, it's still the Z pattern. Okay, and the last one, the C rule. So interior angles are supplementary. What this means is they add up to 180 degrees. So if we have a C pattern, the X and the Y add up to 180 degrees. And remember, these two here, the blues, are going to be the parallel sides. It's kind of purple. And this is going to be the transversal. And just to identify this, we could also have the C pattern backwards. I'll put it in black as well. Okay, where this one and this one are going to add up to 180. It could be like this too. Okay, so those ones would be parallel. So any version of that C could also look like this. Okay, so there's lots of different ways that this could look, but they're all C patterns. And just remember, two parallel lines and then that transversal. In this diagram up here, we just have everything kind of summarized. I'm going to do this in green. Okay, AA and AA, those are all equivalent. And then we'll do like a purple. Okay, BB, BB, those ones are all equivalent as well.
Example 2, find the unknown angles. Okay, so this is just a mixture of different questions from the theorems that we just went over, and we're gonna have to like apply the theorems that we learned and solve for the unknown angles. Okay, so there are different ways to solve these. So for example number 2, if we take a look, like this is the C pattern, right? And because these two are parallel, because they have two little arrows each, we know that like these two could extend out, which is fine. So two parallel lines, and then this is how we would apply that transversal to quadrilateral, is like it would be one of the sides. So if you think about it, 95 and 85, those add up to 180. Okay, degrees. So we can actually do this all the way around. So if you turn your paper on the side, which I can't do here, and we look at the C like this, we would have 85 and this number right here. Well, if we know 85 and 95 add up to 180, this is also 95. Okay, and then if we look at this right here, this would be like a backwards C. So you're getting exposed to it every which way. So this one here and this one here would add up to 180. So again, 95, and we know already 85. So this quadrilateral we can just pattern. And we can solve for those two angles. Okay, just want to take a note, opposite angles here. So 95 and 95, and then 85 and 85. This is a parallelogram. So opposite angles in a parallelogram are equivalent. Okay, the next one, a quadrilateral ABCD with angles. Okay, so it doesn't really matter how you draw this quadrilateral. It's not going to be perfect. Maybe it's going to be like this. Okay, A is going to be 90 degrees, B is going to be 65. And remember, this is not drawn to scale, so that's okay. D looks like it's 90, but it's not. Let's actually solve for D. We would be adding 90 plus 65 plus 55 plus D, and all the interior angles of a quadrilateral add up to 360. Okay, so these add up to 210. 210 degrees plus D equals 360. And if we bring this 210 over, it becomes negative 210. So we would be doing D equals 360 minus 210, and we would get angle D equals 150 degrees. Okay, so this one's interior angles. Okay, we can't use the transversal here because we don't know if any of these sides are parallel. Okay, so never assume. The next one. So I'm also going to apply, I'm going to apply opposite angle theorem too. No, you know what? I'm just going to apply CF and, so we're going to look for C patterns, we're going to look for F patterns, and we're going to look for Z patterns. So this is going to be a backwards Z here. Okay, so angle B is 110 as well. Okay, so Z patterns, these angles are going to be the same. Okay, now we're going to see that this is an F pattern from here to here. And we know that B and C are also going to be the same. So this is going to be 110 degrees as well. Okay, and there's no C pattern here. There's no F pattern. You know what? Without solving this with supplementary, so we can say that A and B add up to 180, or we can do patterns. So these two are equivalent, and then these two are equivalent. So A is going to be the, let's say the other one. So angle A is going to equal 180 minus the 110. So angle A is 70 degrees. And if you label this 70, so like an orangish. Okay, and these two, all four of these are going to be equivalent as well. Okay, one that you can sometimes use is opposite angle theorem. So if two lines intersect, then these two are going to be the same angle, same measurement, and then these two are going to be the same as well. So that's called opposite. Again, I'm going to try to stick to C, F, and Z. So in the next ones, we have two lines and a transversal through them. I can see that this is an F pattern. So angle C is going to be 75 degrees as well. And then let's just use that opposite angle. So 75 and 70, and A is going to be 75 as well. Okay, and then we know that this is going to be green, this is going to be green. So these four are going to be equivalent. This is going to be the 180 minus. So angle B is going to be 180 minus 75 is going to be 105 degrees. Okay, example 3, find the measure of the unknown angles. So in this, if you take a look, we have Z, W, X, then 4X plus 10, X plus 3, U, 2X minus 5, and Y. So you're taking a look at this and you're saying, like, where do I start? Okay, so I'm going to say this. What we can do is I'm just going to bubble all of the angles with an X in them. Okay, so U, W, Z, and Y, we can't do anything with because we don't have, we can't solve them. Like, we don't have a theorem to say, oh, these two add up to this much or whatever. So where I would start here is we know that these two angles add up to what? 180. So we know X plus 4X plus 10, right? We have angle X, and then we have angle 4X plus 10. These are going to add up to 180 because these are supplementary angles. So we have 5X equals, let's bring that 10 over, 180 minus 10. We have 5X equals 170. Okay, so if we were to solve for x, we get 170. We get 34. Okay, so x is 34 degrees. So that's fine. We can say that this is 34, but this in here is not 34 because it's actually, I'll do it up here, 34 plus 10. And what does that equal? Well, that's 68 plus 10. So that's 78. So this angle in here, oh, sorry, 4. Here we go. I did 2. So we get 136 plus 10, which is actually 146, which makes more sense because I was looking at that double digit, and 146 plus 34 is going to equal 180. A double digit and 34, like it's as low as that number was, it wasn't going to add up to 180, and that's how I caught that. Okay, so those two are done. Now 2x minus 5, well, let's sub it into there too. So 234 minus 5, that one's 68 minus 5, and we get 63. Okay, so this angle here is 63. Okay, and then x plus 3, well, we have 34 plus 3, so we get 37. So this angle in here is 37. Well, supplementary angles are really easy to solve for. So we can do angle y equals 180 minus 63. And I get 117. Okay, 117 degrees. You can double check that those two numbers add up to 180. And then I'm going to do supplementary angle theorem on these two. So angle U is going to be the 180, but we're going to subtract 37 this time. Okay, and we get 143. Okay. The interior angles of a quadrilateral all add up to 360 degrees. So we know that angle W is going to be that 360 minus 146 minus 63 minus 37. Okay, and I get 114 degrees. Okay, so that's 114. So then here's the thing. I'm going to do this kind of the long way. I'm going to do angle Z or Z as the exterior angle, instead of just doing like the supplementary, because that's easy, right? But we know that the exterior angles add up to 360. So let's subtract the 143, the 117, and the 34. And then we do the 360 minus all three of those, and we're going to get Z. Okay, and I get 66 degrees. Okay, you could have used supplementary angle theorem as well.